like, oh, let's go. Let's see what's going on in Antarctica. I saw this. I was like, satellites show world's glaciers are melting faster than ever. And I was like, oh man, that's kind of alarming. Melting faster than ever. Click the article. Half of the world's glacial loss is coming from the United States and Canada. I don't know. That sounds terrible. Then I was like, wait a second. There's a major Greenland glacier growing. Now, that's not really in the United States or Canada, but it's close there, and it's a really big one. It's not like a minor one. So I was like, okay, so glaciers are melting in Canada and the United States. Well, most of them are melting, but not all of them. Some of them are actually growing. This one's growing, and apparently this one has been growing like 3 years straight. The third straight year of thickening of Greenland's biggest glacier supports our conclusions that the ocean is the culprit. Apparently the ocean brought a bunch of cold water up there like 3 years ago. And it's still growing. But this is a nice little time map of this. See, in 2016, 2017, this blue part is the glacier. And it's like, oh, that's pretty small. 2017 to 2018. Oh, wow, that's like, it's really expanded. In 2018 to 2019, it's gotten a little thicker over here. It's taken over some more spaces over here, but it's gotten much thicker. And that's just the glacial height of the glacier. That's the height change in the glacier, right? So it just shows you that you got all this red, which is low, and it just gets higher and higher and higher. And they say the change is particularly striking at the glacier's front between 2016 and 2017. That's when it advanced the most, replacing open water and sea ice with towering glacial ice. That's pretty interesting. And they think it's reacting to a shift in a climate pattern called the North Atlantic Oscillation, which has brought cold water northward along Greenland's west coast. Measurements of the temperatures collected by the OMG team show that the cold water has persisted. So it's been getting hit with cold water for quite some time. But it says even 3 years after the cold water arrived, the glacier is still reacting, Willis said. I'm really excited to go back this August and measure the temperature again. Is it still cold, or has it warmed back up? And so these statements are actually kind of, they don't really add, not really consistent is what I'm trying to say. Because if they're saying that the cold water has persisted, it means like even after 3 years, the cold water arrived. So I'm thinking the water kind of arrived and it didn't arrive, but I guess it just arrived and still been there. So good. You got a nice, huge, major glacier in Greenland growing. But, that doesn't necessarily mean that the world's glaciers aren't, all melting still. And then I was like, wait a second. NASA study. Mass gains of Antarctic ice sheet greater than losses. A new NASA study says that an increase in Antarctic snow accumulation that began 10,000 years ago is currently adding enough ice to the continent to outweigh the increased losses from its thinning glaciers. Okay. According to the new analysis of satellite data, the Antarctic ice sheet showed a net gain of 112 billion tons of ice a year from 1992 to 2001. That net gain slowed to 82 billion tons of ice per year between 2003 and 2008. Now, it's important to note this is from October 30th, 2015. Right? It's not necessarily new. I went back to this little thing here. I remembered seeing this. Huge Antarctica ice shelf at risk of collapsing. And I was like, Daily Telegraph. I don't really trust the Telegraph as a news source. Oh yeah, we got Biden over here saying climate crisis. Researchers fear global tipping points already here. I just, love remembering my last little, not my last stream, but the one before that, James Carville interview, where he said that climate change is not employing emotions, not using people's emotions enough to make them just get it, But this is crazy. And then I started to go on this whole tangent. This whole weird tangent. Because I was like, okay, if some glaciers are growing and others are shrinking, like what's the deal? What's going on, right? I figure if the climate, of the entire planet, right, was warming or cooling, then it would be all glaciers growing or all glaciers melting. Now, they do seem to think that, just because there's a little cold water here that's making this one. So it's like, all right. But then I started to go into my own little research. I was like, okay, let's just take a look at the difference between true north and magnetic north. Because I just have a theory. Okay? I just have a theory. And my theory is essentially that if the magnetic north or true north is moving, essentially, and I'm actually not able to even prove this thing because I've delved even deeper into it, and you've got the axial tilt of the Earth, right? And then you've got true north, and then you've got magnetic north. Now, I'm under the idea that the glaciers kind of react with true north and magnetic north. And I'm also under the idea that the axial tilt of the planet is tied to magnetic north. Now, the way, and I'm just going to try to support this as best I can, because I've already read through all this stuff, but I spent quite a bit of time going through this, and so my mind is kind of fried, and I've been chasing this raccoon off. I go out to try to feed the cats, and there's this, it's this crippled raccoon, but it's been crippled for forever, and every time it comes out there, it starts hissing at me. And at first I was like, yo, here, have a little food. But now I'm just like, fuck off. Like, fuck off, you fucking raccoon. It's just the most aggravating thing. It's not as bad as the possums, as in it doesn't eat all the cat food. The possums, no matter how small they are, will just eat it all. They'll even be throwing it up and still eating it. It's just like, what the fuck is wrong with you fucking possums? But the raccoon will just, eat enough and then run off. But I'm just really tired of it hanging around, because we do still have kittens, little small kittens. We have a bunch of cats had kittens recently, and I saw a video online of a raccoon attacking a mama cat, trying to get at the kittens, and they getting into a fight. And I don't want that shit going down here. Right? I mean, if it did go down and I caught that fucking raccoon, I would do what I wouldn't do what the person in the video did. They were afraid to get involved, but I would at least kick the damn thing. It's pretty fast for a crippled raccoon too. It's pretty fast, so it can run away from me. It can dodge, it can weave, it can do all these things with just this one back leg, because it's got these two front legs and one back leg, and the other back leg is all messed up. And at first I felt sorry for it, but now I don't feel so sorry for it. But anyway, I went through this chart. Well, this guy did all this work on this website. We basically plotted it, mapped out the degrees, all this stuff. And he finally came up with this thing here, which I found to be pretty interesting. And I looked at this and I was like, okay, 1750 to 1850 kind of had this huge jump here, right? Now, it was here. It's supposed to be here. Okay, it's supposed to be here. So right now, it's actually closer to where it's supposed to be than it was, way back in 1850. And so at first I was like, what happened in 1850? A bunch of people died, a bunch of people were born. Harriet Tubman started the Underground Railroad, all sorts of stuff. But the main thing to note here is that the Industrial Revolution was between 1750 and 1900. And what's interesting about that is 1750, 1900. This guy's got it mapped out. 1750 to 1900. So during this period of time was the Industrial Revolution. And so during the Industrial Revolution, magnetic north found itself all the way over here, basically inside Canada, well, in northern Canada, right? And I was like, huh, that's pretty interesting. But the Industrial Revolution kind of ended around 1900, and magnetic north has been slowly, over the last 100 years, been making its way up here, where around 1975, it started to pick up and move this way, right? Now, the year 2000 is interesting to note here, because even though 2000 is 25 years after magnetic north really started to pick up and move back this direction, the year 2000 is when, where we at? Right. The year 2000 is when the axial tilt of the Earth, right? Around the year 2000, Earth's spin axis took an abrupt turn towards the east and is now drifting almost twice as fast as before, at a rate of almost 7 inches a year. Now, gosh, I don't know how I'm going to explain this, but my theory is you've got the Earth, you've got it rotating towards the east, right? It's rotating this direction, it's got the axial tilt. Now the magnetic north moves this direction. The Earth is still spinning, right? And so its tilt isn't going to, go directly, it's not going to follow magnetic north perfectly because of its spin. And so it's going to kind of move like this as it moves back up, right? It's gonna move east and up, but it's gonna be like this curved movement because of the mass of the Earth spinning in that way. That's just kind of how I'm going with it. And so what they're saying in this NASA.gov study, which they're really just referring to a study that was published here in a paper published today in Science Advances. Surinder Adkike and Eric Ivins of NASA's Jet Propulsion Laboratory, Pasadena, California, researched how the movement of water around the world contributes to the Earth's rotational wobbles. And that's a pretty fair, thing to look at. I would say the mass of water on the Earth is huge. It would have a giant effect on the planet if, a bunch of water moved in one direction. You would think the Earth would, kind of want to follow that because of just the sheer mass of water on the planet. That's pretty fair. However, reading through this, right, let's just continue here. Around the year 2000, Earth's spin axis took an abrupt turn towards the east. It is now drifting almost twice as fast as before, at a rate of almost 7 inches a year. It's no longer moving toward Hudson Bay, but instead toward the British Isles. Right? That's a massive swing. We go back here. We notice that, these people, they are in California. So California's down here around this way. And they're saying that the tilt of the Earth is moving, the tilt of the Earth is moving east in a massive way. And so that's technically this point here, I think. But they have this mapped out, and I don't have something to kind of overlay this with the axial tilt, because I don't think the axial tilt is representing this point here. I think the axial tilt is more because okay, hold on, I gotta really just try to explain this. But what I'm thinking is that you've got magnetic north, and then you've got true north, which is this 90-degree thing. The red dot is magnetic north. Now the whole point is to have this thing kind of right here, which it's actually kind of close in this year. But they're talking about in the year 2000, the tilt started to move. Now the axial tilt is not going to be magnetic north. But I want to argue that, and I don't have, any kind of grant or scientific data necessarily tied to this. I tried to find it, but I couldn't really find anything that, was like, yes, the axial tilt of the Earth follows magnetic north. Nothing like that. But I think the massive amount of momentum that the Earth has, it's very difficult to move it in space like one way or the other. And I believe that the only thing that could really do it is magnetic north, because that's a huge part of the planet, and it's a very strong force. But what they want to argue is that they had suggested the loss of mass from Greenland and Antarctica's rapidly melting ice sheet could be causing the eastward shift of the spin axis. They assessed the idea using observations from the NASA German Aerospace Center Gravity Recovery and Climate Experiment satellites, which provide a monthly record of changes in mass around the Earth. Those changes are largely caused by movements of water through everyday processes such as accumulating snowpack or groundwater depletion. They calculated how much mass was involved in water cycling between Earth's land areas and its oceans from 2003 to 2015, and the extent to which the mass losses and gains pulled and pushed on the spin axis. Now, their calculations showed that the changes in Greenland alone do not generate the gigantic amount of energy needed to pull the spin axis as far as it has shifted. In the southern hemisphere, ice mass loss from the West Antarctica is pulling, and ice mass gain in East Antarctica is pushing. That's what they're claiming, and I think that's a fair claim. I think it's a fair theory, but I believe that it's more magnetic north. I think the magnetic poles of the planet have a much larger effect on the axial tilt of the planet than the combined ice sheets. And they're saying that even from the ice mass loss, that the changes in Greenland didn't really generate the amount of energy. And then they look at Antarctica and they're like, okay, let's combine the two and see what's happened here. The Earth spin axis, okay, and ice mass needs to ask her to push Earth spin axis in the same direction that Greenland is pulling it from the north. But the combined effect is still not enough to explain the speed up and new direction. Something east of Greenland has to be exerting an additional pull. Now it says something east of Greenland. Well, here's Greenland, and here's the magnetic north. Now, according to us, this is not east of Greenland, right? This is not east of Greenland, but it is north of Greenland, right? So we go back over to their study. They say they found the answer in Eurasia. Wait, no, okay, no, we go back here and we reread this again. Read the Earth's spin axis in the same direction that Greenland is pulling it from the north. So they're saying that Greenland is pulling it from the north. But what's north of Greenland? The magnetic North Pole. The magnetic North Pole is north of Greenland. And so, while, you might say, the ice accumulation up here would have, I believe, an effect, they're saying, it's not enough. It's just not enough to do it. And I say, what about magnetic North Pole? Could the combined effect, or even just, magnetic North Pole by itself, be pulling that tilt in that direction? Because, we have to remember that it's spinning east. The Earth is spinning east. And so if the tilt's moving east and north, then I'm thinking the tilt is moving with magnetic north. And apparently, when this is something that maybe wasn't easily picked up on back in between 1900s and 2000 because of how slow the magnetic North Pole was moving. But then when it started to pick up in 1975, I'm thinking that it took 25 years effectively for the momentum of the Earth to kind of shift in that direction. And then once it started to go kind of shift in that direction, it started to pick up and accelerate, as you can see here. I think it is accelerating and trying to follow magnetic north. And I just think that magnetic north would have kind of a larger effect on the axial tilt than, say, the mass of this stuff. And what's interesting is they don't really get into magnetic north at all in this article. But they seem to say, okay, that wasn't enough. Something east of Greenland has to be doing this. And then they say they found the answer in Eurasia. They say the bulk of the answer is a deficit of water in Eurasia, the Indian subcontinent and the Caspian Sea area. The finding was a surprise. The region has lost water mass due to depletion of aquifers and drought, but the loss is nowhere near as great as the change in the ice sheets. But that's okay, because they try to go on and explain that this is, so, why does the smaller loss have such a strong effect? Because they're kind of sticking with this depletion of water theory. They're saying the researchers say it's because the spin axis is very sensitive to changes occurring around 45 degrees latitude, both north and south. And then they suggest that this is well explained in the theory of rotating objects. And that's why changes in the Indian subcontinent, for example, are so important. And I was like, you're using the theory of rotating objects? And I don't know much about the theory of rotating objects, but I know a theory is not as good as a law when it comes to math. But I went ahead and I was like, let's just take a look at it anyway. Rotation theory. I looked at this, and I tried to read it. But I've been out of college for so damn long. I understand what these things mean. Well, most of them, right? I mean, I know that's rho, and they've got 3 variables there that equals as something approaches infinity, as n approaches infinity, right? So it'd be one of this. This actually gets smaller, right? As n approaches infinity, this number, this part here, this multiplier, is going to go to 0. It's just gonna get smaller and smaller and smaller as n increases in number. And this, what is it, the derivative or the integral of this equation here, and we have to really kind of take this equation from up here. And I was like, ain't no fucking way am I doing that for a YouTube video. I was like, no way. I'm only really doing this for like editing, and I want to get into special effects. So hopefully I'll get some special effects on this next one. But this one, I'm all over the place with this one, so who knows. But this is what it is. They're using this theory here, and I'm just like, yo, a law is an observation. A theory is the explanation of that observation, but it's still a theory, right? A theory requires experimentation under various conditions. A law has no such requirements, and a theory may become obsolete with time. So the reality is, this theory right here, I think, can become obsolete with time. Because if they're saying that at 45 degrees, that the reason why water accumulating in Antarctica and water either being lost or accumulating in Greenland is like, it's a huge amount more ice. It's a ton more weight, but it doesn't have as much of an effect. Now the 45 degree angle, 45 degrees latitude kind of makes sense. That's kind of like, I think it would be more effective, right, if the accumulation or the depletion happened at the equator, right? Because you're kind of talking about like leverage, right? And if you like grab something and you wanted to move it somewhere, your best place to grab it is kind of a perpendicular thing. So if this is like the axial tilt, then you're going to get your most amount of like leverage force from over here. You grab this, you'll be able to do that. 45 degree angle, kind of similar. Up here, you might think, grabbing it, yeah, but that's kind of where all the, there's a lot more forces going in that direction. There's a lot more forces occurring in that area, particularly when we're talking about, planet Earth that is rotating around this thing. right? If you really wanted to affect it, right? You take it's like a basketball. If you're spinning a basketball on your finger, you're hitting it on the side here in order to make it spin and still kind of stay in this top part here, right? You can hit it on like the 45th degree angle there, and it would still kind of do the same thing. If you kind of did that on the top, it would screw your whole ball up because, well, it's a ball, but if it was a lot bigger, it would be a lot harder because it's spinning like that. But that's kind of what I took it as. It's like, okay, that makes some sense in terms of the theory of rotating objects, but I also found the idea that like the Indian subcontinent water is apparently the big problem here, and it just made me think of kind of like Bill Gates going to India and talking about the farming over there, and I was like, they are trying to like get their grubby hands on India's farming for some reason, trying to do something. They're trying to do something over there with India and its farming. And so I just found it odd that they're, going to sit here and say that the depletion of groundwater in India is the reason why the Earth's axial tilt is moving back to where it ought to be, in my opinion, because this is just something that comes from something I read in the Bible a long time ago. But it was literally God saying that man kind of like screwed up their planet by tilting the earth with pollution. And so ever since then, I've been like looking at any kind of science that would say yes or no towards that. And I came across this, and they're telling me that like a small amount of groundwater depletion in India versus a huge amount of ice accumulation in Antarctica is what's causing this. And I'm just like, okay. And then there's Greenland, where that Greenland has a massive amount of ice accumulating on it. And of course, that's not going to affect it as much, but the groundwater depletion in India is what's doing it. That just seems like kind of a stretch to me. Now, I'm not by no means any kind of an expert, by no means, I guess, because I figure if you want like a nice stable planet, then you're going to want your axial tilt to kind of be in line with magnetic north, and you kind of want your magnetic north to be in line with true north. Right? Now, the reason I think this is because with the Earth tilted, we kind of get like the winters and the summers, and that kind of a difference, but that's just kind of like Earth being tilted. But I also think that the Earth kind of being tilted, if it's like tilted towards the sun, that it kind of will slowly drift towards the sun, and therefore the Earth could warm up that direction, that way, because it's getting more of that radiation from the sun. And then, there's the opposite problem, where if it's tilting away from the sun, I think it would slowly drift away from the sun, and the Earth would cool. And so I'm just trying to explore the internet to find out if there's any data on it. And what I think I've discovered from this data is that yes. Now, they have a theory as to why the axial tilt of the Earth is moving. I don't necessarily buy their theory, but from this article, it does say that the axial tilt of the Earth is in fact moving. And it is in fact moving east and north. Right? Now, if it's moving kind of like this, right, I think it's following magnetic north. I think magnetic north isn't going to be, constrained by the momentum or the rotation of the Earth. I think it's just going to kind of move up and wobble around. And I don't expect it to, like, you know, find its way here and then, like, just stay perfectly there. No, I would expect it to kind of move around, like, in this area. But that's what I would think would be the kind of sign of a healthy planetary orbit. You know, planetary rotation. I just, that's just what I think. I don't, you know, I haven't seen anybody else talk about this. I've been trying to find data on it. I don't know, but that's what I think, right? And I kind of take it from what's interesting here. I take it from kind of the Bible saying that man kind of screwed things up, kind of screwed the tilt of the earth up. And I'm like, that's very interesting. Then if that's true, then maybe we would see something like that here in real life, in real day, in real time. And when I look at here, I'm like 1750, 1850, or 1900, 1750, 1900. That's the Industrial Revolution. That is literally the Industrial Revolution. And I can go back here and say Industrial Revolution, 1750, 1900. That's what it is. Now, if we say, okay, what could possibly push it? And I think their idea that, like, water accumulation, ice accumulation, I think it actually does have an effect. I think it's actually part of it. That's actually part of my theory, is that the Industrial Revolution and that kind of processes generates a huge amount of heat. A huge amount of heat. And that goes up into the atmosphere and it blows off someplace. Now, if I look at here, where was the Industrial Revolution mostly during this period in time? Well, it was over here. It was England, it was Europe, right? Now, between 1750 and 1850, the Industrial Revolution going on, you know, they had stacks and stacks of just coal burning and just tons of smoke billowing and just a huge amount of work going on. And that all was happening up here, right? And so that would kind of push. Now, but it's kind of backwards though, right? Because at least I think it's kind of backwards. Just because, oh gosh, how do I state this? If this is where all the heat's coming from, then if this is where all the heat's coming from, then this is where all the snow and ice and water would be, like, melting, right? The heat would be kind of pushing against the coldness here. And so then effectively would push the earth in that direction, because the axial tilt of the earth is following magnetic north. Now, how the hell does it affect magnetic north? How would heat affect magnetic north, right? Because if my theory is that the axial tilt of the earth follows magnetic north, then the heat would have to be effectively affecting the magnetic north or pushing magnetic north. Whereas there's also the possibility that the heat actually just affects the true north, and then true north is what's kind of being pushed around, or the axial tilt, because at the axial tilt is kind of where all the ice is accumulating and stuff. And so this is very much still a work in progress, a theory in progress here. I haven't quite figured it out, and I probably should have spent more time on it. But oh my gosh, I just wanted to get into it, and I thought I had it, you know, pretty well set out in my mind, but I didn't write anything down. Oh gosh, but yeah, that's effectively what I'm looking at here, because I think I am on to something somewhat with this study that's suggesting that, yeah, the tilt of the Earth's spin axis, which is the axial tilt, so, around the year 2000, moved. It started moving twice as fast as before. That's what they're saying. Well, you'll notice that at some point in time, true north started, or magnetic north started moving twice as fast. It started to really accelerate and pick up. And so that's what makes me think that there is a correlation, there is a tie, and that's what makes me think that the axial tilt follows true north. But then, we're talking about the accumulation of ice and water in places, or the depletion of ice and water in places. And so there very well could have been a huge depletion of water and ice in the areas where the Industrial Revolution was taking place, such that magnetic north and the axial tilt both found their way like being pushed this direction. So it makes me think that magnetic north is in fact tied to axial tilt. From this article, though, it makes me think that axial tilt follows magnetic north. However, that would mean magnetic north, according to my theory, would basically be following the accumulation of water or ice, which doesn't make any sense to me whatsoever. Right? What possible tie could there be between magnetic north pole and water? All right, like gravity doesn't have a huge effect on magnets, right? But that's essentially what I'm doing. That's essentially what I'm doing tonight. Is I'm working on my theory of why this stuff is happening at all. Right? Like why glaciers are melting in some places and growing in others. Why climate change is more, connected to the tilt of the Earth and magnetic north than it is to CO2 emissions. Now, there's got to be a lot more involved, right? There's got to be a lot more variables involved. These guys are claiming in their study that the depletion of water in the Indian subcontinent in the Caspian Sea area is causing the axial tilt of the Earth to move. Now, what's odd about that to me is the Indian subcontinent is surrounded by an ocean. Basically, it's basically surrounded by an ocean and snow-capped mountains. It seems like it's got a lot of water mass in the area. They got huge rivers. So, yeah, because my whole thing with the Industrial Revolution is that all the heat and gas and all that stuff produced, and perhaps even the water depleted in the process, right? Because we used a lot of water. It was steam engines. Everything was steam engines back there. And so it was take water, boil it, use that pressure to turn something, to push something, to do some work. And, I just find it incredibly interesting that between the years 1750 and 1900 is when the Industrial Revolution was going hard, and that this is that magnetic north would be in this area, would hang out in this area, and these specific areas for the time period of the Industrial Revolution. I think this little jut out here may be like normal magnetic movement. Like for instance, if a magnetic pole was here, I think you'd see these normal little like juts outs and stuff like that, like a little movement. But little small ones like these. Right? This whole thing where it's just like this massive movement this direction, and then it starts to slowly come back this way, and you might think, oh, maybe nukes had an effect. It doesn't look like nukes had a huge effect. I don't know, but it doesn't seem like it. I'm like looking at this, and it's like, okay, 1950s to this time period, there were definitely a lot of nukes being tested, and Russia is over here. And so it did kind of do this, right? The United States was down here, and this is where all the nukes were being tested, over here in the Pacific Ocean and stuff. It's definitely still a work in progress.